Number 1. In the example, is the probability that Alexis rolls 2 odd numbers the same as the probability that she rolls 2 even numbers? Explain. So in the example, she did the probability of rolling an even number on both cubes and got 9 over 36 and 1/4. Yes, it is the same probability that she would roll 2 odd numbers as she would 2 even numbers, because there are the same amount, the same number of odd numbers and even numbers in the sample space. And so the probability would be the same as well, 9 over 36 and 1/4. Number 2, what is the probability that Alexis rolls a 3 and a 4? So for it to be 3 and 4, it would have to be this number here and this number here, which is 2 over 36. But remember, we have to reduce that down to 1 over 18. Number 3, Austin spins the spinner 2 times. Draw a tree diagram to show the sample space. Identify the probability that Austin spins the same number on both spins. So if we're spinning it, we have 3 possible options. He can spin a 1, he can spin a 2, or he can spin a 3. That's for the first roll. Then for the second roll, again, he could spin a 1, 2, or 3, but you have to do it for each set of numbers. So my total amount here would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my total number here is a 9. That's my denominator. The numerator, the number on top, is what we're looking for. If we're looking for him to spin the same number, that would be a 1, 1, a 2, 2, or a 3, 3. There's 3 possible answers. So 3 over 9, we reduce it to 1/3. Number 4, Bella spins the spinner 2 times. What is the probability that she spins at least a C at least 1 time? So again, we can make another tree diagram, except this time we have 4 possible answers. We have A, B, C, and D. And so when we split it off again, we have to do A, B, C, and D both times. We have to do it for all 4. I can look and see I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is my denominator, because that's my total number at the end. And if we want a C at least once, that could be AC, BC, C in any of those 4, CA, CB, CC, CD, and DC. So that'd be 1, 2, 3, 4, 5, 6, 7 times. Again, if I listed them out, it would be AC, BC, CA, CB, CC, CD, and DC. 7 over 16. Number 5. Deacon is playing a game in which he rolls 2 number cubes on his turn. He needs to roll at least a sum of 7 on his next turn to win the game. Is there a greater probability of Deacon winning or not winning on his next turn? Explain. So we did this problem yesterday in class. We said that it was for when we were comparing Dave and Jess in the example problem in the textbook. We said that Dave's probability of getting a sum of 7 was 6 out of 36. Okay, if they had the table diagram in the textbook where it listed out all 36 possibilities, and 6 of them had a sum of 7. If I listed them out for you right now, it would be 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Now, that means he has a 6 out of 36, or we reduce that down to 1/6 of a chance of winning. Meaning there is 5/6 chance that he will not win. So there's a greater probability of him losing the game rather than winning the game.